If you've been at least a bit active when it comes to Flutter packages in the last year or so, you have surely heard about Riverpod, a reactive caching and data binding, or as some would say, state management package that is sort of an upgrade of the beloved provider. I actually covered it with a tutorial quite some time ago when its API was still unstable, but Riverpod has come a long way since then. It's much more mature, helpful, and versatile. And all of these changes naturally mean that it's time for a new tutorial to prepare you to fully utilize the power of Riverpod 2.0 and most likely also its upcoming versions. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. So what actually is Riverpod? Well, its purpose has a lot in common with classes and packages which you probably already know, but you probably also know about Riverpod. Nevertheless, those packages and classes are inherited widget, provider, getIt, and partly also getX, because a part of it is also focused on state management and on providing things around the app in one way or another. But what sets Riverpod apart from all of these options that are just jumping at you from all the different sides? Well, it's the fact that Riverpod combines ease of use, clean coding practices, and complete independence from Flutter, which is, by the way, great for testing. Also, compile time safety is in here, as opposed to dealing with runtime errors. And at the same time, Riverpod also offers performance optimizations. All of this you have in just one package. And naturally, this makes it a great option for your state management / providing things around the app needs. And also, Riverpod has quite a unique approach to how you do all of this, which is unlike all of the other options out there. Now, let me also preface this by saying that if you are a total beginner in the Flutter state management scene, then this tutorial may not be for you. If you don't even know what a stateful widget is, then please go ahead and check out this official documentation. These Flutter docs will get you up to speed with everything you need to know. And once you know the basics, you can come back here and learn about Riverpod, all right? And by the way, all of this, which I'm scrolling through here, the link to this is in the article, to which you can get from the link in the video description. And besides a link like this, links to documentation, link to the Riverpod package, and all other kinds of links from that article, which is linked in the description, you can also find all of the code written in this video and go through this lesson at your own pace. Now, the version of the package we are using in this tutorial is Flutter Riverpod 2.0.0 Dev 5. All of the content of this tutorial is going to be fully valid for once the actual stable and non-dev version comes out. So that's totally fine. If you're working with the stable 2.0.0 or 2.0 point something version, that's totally fine. And I think actually that at least the majority of what we are talking about in this tutorial is going to work, even if there is at some point in the future Flutter Riverpod version 3.0, just saying. And before we get to actually our VS Code and creating some actual app, let us just first go through some of the basics in this presentation form. If you want to provide or make accessible a string throughout your app using Riverpod, this is how you would do this. Now, this is really different than with any other provider type solution you may have out there, right? I actually have an older article which compares Riverpod with the regular provider package, and that is also linked in the article, to which you can get from the link in the video description. But just briefly, if you look at this and you're familiar with the provider package, you know that, well, the provider package declares its providers in the widget tree, but here we declare providers somewhere. So where is it? It's actually top level. So this is outside any kind of a class, outside any kind of a method. This is just top level final variable. This is also different from any kind of a service locator type of thing you may have going on, like get it. We are not registering anything anywhere. We just simply do this. And what are we actually doing here? Well, if we break this line of code down, we are just declaring a provider, giving it a name my string provider. And this provider is the simplest type of a provider, because there are multiple types like future provider, stream provider, I don't know, change notifier provider, what have you. But this is the simplest type of a provider, which simply will make sure that we provide this hello world string. And this ref parameter, we are going to get to it in more detail, but this is just used to interact with other providers. Again, towards the end of this tutorial, we're going to get to this ref parameter, which is of type provider ref. So this line consists of declaring a provider with the name my string provider, and then actually saying that my string provider will provide the string hello world. And by the way, just so you know, from now on, we're going to call the object being provided by the provider state. So state in this line would mean hello world string. If we think about it, this provider declaration is very similar to how you would declare a regular class. And also what's similar is the global nature of the declaration of the provider, but the provider itself not being global. Now, what possibly can I mean by this? Let's check it out. So here we have an example with a class, which is much more easy to think about. Just like for a provider, a class also has a declaration and a name. In this case, of course, the name of this class is my class. And then also we can use not the class really, but we can use an object of the class, an instance of the class. While the class declaration is of course accessible globally, the instances of the class are not global. This object is not global, right? This is not a static class after all. You have to instantiate it, and once you instantiate it, this is just like one object, one separate thing. It's not global. You can, for example, pass it to a function, and from this function, the only myClass instance you can use is the one which is passed into it. You have no other object to use. You cannot just use something globally, right? I'm probably repeating myself by now, but it's very important for you to understand. In much the same manner, a provider declaration, like we have here, declaration, is global, but this is not a global variable as some critics may say. Sure, the declaration is global. This is what this variable is talking about. It is a global variable, my string provider. But once you actually work with the state which is provided, this state will not be global. It will work pretty much in the same way as with this myClass object. That's because the state of providers is managed by a widget called provider scope, and we are going to take a look at it very soon. And this provider scope widget keeps our app maintainable and testable. So essentially, we could really say that Riverpod gives us all the benefits of global variables without any of their drawbacks. We can use them from anywhere and get to their state from anywhere, but they are not global. They're actually managed by provider scope, which is very smart about how it manages them. So let's now actually get to some real code in VS Code. Here we are in VS Code, and before we do anything else, just make sure to go into your pubspec.yaml file and add Flutter Riverpod 2.0 point something or dev 5 if you're watching it fairly soon to the date of release. And you can of course copy this version number and also get all of the code that we already have here or that we are just about to write from the article linked in the description. So what are we actually going to build here? As you may have guessed by this title, yes, we are going to build a counter app, but this is not going to be just another simple, stupid counter app. We're actually going to expand on it, and eventually we are going to even involve WebSockets, kind of fake WebSockets. We're going to involve a stream, so it's not going to be your run-of-the-mill counter app that you all know and hate, right? So this is something a little bit more exciting, I promise. So how is it going to look like, or at least one of its version is going to look like this, because again, we're going to build multiple different kind of versions of this counter app to showcase different aspects of Riverpod so that you can learn a lot about this Riverpod package, of course. So this is what we are now going to focus on in the upcoming few minutes of this tutorial. So we are going to build an app which has a home page. We can go to the counter page where the actual counter is hidden. Then we are going to be able to, of course, increment it, right? We can increment it. And eventually we are also going to add a functionality to reset the counter from here, right? And when we increment it, come back to the home page, come back to the counter page, the state will be preserved, but we are also going to look at the way how to not preserve the state when we go to home page and come back to the counter page. So we're going to cover all of this and even some more with the kind of fake WebSockets and streams and all that good stuff. So you have a lot to look forward to and a lot to learn here. So what we have here currently in VS Code doesn't really involve Riverpod in any kind of way, because what we have here is really just a My App widget, which is the top level widget, which has a material app called Counter App. The Home widget is just a empty container as a placeholder, and then we just basically do some theming related stuff like theme data, and we set it to green so that it looks nice. So what's the first thing we should do if we want to build a counter app? Well, we obviously should declare a counter provider. So much like you have seen on the slide before, the way to declare a provider using Riverpod is to just declare it globally. Now we're going to do this inside of main.dart, but obviously if you are working on a larger project, you can of course declare your providers in separate files so that you can keep your stuff organized and not just in one huge file, and you just don't want your projects to become a mess. And actually, if you are the type of person who likes to write good, clean code, build really good apps, and progress in your software development career, to work on more exciting projects, and also, of course, to work on projects that pay you more, whether you want to be a freelancer or you want to work at a job in an office or do remote work. If you're that kind of person who likes to progress in their Flutter development career, then you might be interested in checking out the Flutter Developer Bootcamp, where I take you through the journey of building real-world apps very well in a maintainable manner so that you can become an asset to wherever you work or whatever project you want to build yourself so that they are going to be successful. Now, I'm not just talking about any kind of a course, it's actually a bootcamp, because you have me available on the Discord server, and also you have me available in weekly live Q&As where you can ask any kind of question even the tough ones, and you're going to get all of your problems sorted out. And also the curriculum of the Flutter Developer Bootcamp is built in a way that you will truly see progress day by day as you go through it. And again, if you arrive at any kind of issues, you have me available to sort them out. So if you're interested in all of this and you would like to become the best Flutter developer that you can be, check out the Flutter Developer Bootcamp from the link in the video description. So what do we want to do? We want to create a counter provider. So that's going to be a final counter provider. And this is not going to be just the standard provider as we did in the slides for the simple string, because actually we want to be able to increment the integer, which is going to be basically the counter. And this basic standard provider is read only. You cannot modify the value from the outside, but we actually want to increment it from the outside. When a user presses that well-known floating action button, the counter should increment. So we do want to modify it from the outside. So what do we want to do? Well, it's not going to be just a provider, but it's going to be another type of provider, state provider. This state provider is very useful for managing these kinds of simple states. In this case, we have a counter, but usually in some real world apps, you would have like individual, like, I don't know, toggles, like booleans in here, not very complex stuff really. For complex things, there is state notifier provider. You can also use Qubit with Riverpod, which is something we're going to take a look at later on, sometime in an upcoming tutorial, of course. You can, of course, use also block with Riverpod. Therefore, you can use streams, futures, everything has its own provider. And the state provider is really just for some simple state. So the creation function, of course, takes the ref, which we're going to take a look at later on. But for now, we don't really need to worry about it at all. And we just provide 0 to be the starting point of our counter. So this makes the counter provider a state provider int. Byte type inference works wonders, so we don't need to write the type parameter here ourselves. And now to make Riverpod actually work with Flutter, because believe it or not, Riverpod also can work with just pure Dart apps. You don't actually need to use Flutter for Riverpod to work, unlike with the default original sort of provider package, which just is purely widgets. It cannot work without Flutter, and it kind of depends on Flutter, right? Riverpod is completely independent of Flutter. It doesn't depend on it. The way you actually make Riverpod work with Flutter is by wrapping your top level widget, in this case it's called my app, with another widget which is called provider scope. And that's pretty much it. Right? Let's just format this. It looks nice. This provider scope is the only widget we are going to really write when it comes to Riverpod, or at least the only widget which wraps something, right? Should I say. So again, unlike with the regular provider, you are not going to be wrapping a bunch of widgets with provider here, provider there, everything will become cluttered. No, with Riverpod, you just have one widget that needs to wrap something, and it wraps the top level widget, right? And otherwise, your providers are declared like this top level variables, basically. This provider scope is therefore responsible for managing everything and keeping everything in line with how Flutter works. Everything will be disposed properly. When a widget is disposed and the provider is attached to it, basically, the provider is also going to be disposed if you tell it to be. We're going to take a look at that later on. But just so you know, everything is managed properly. There are no like memory leaks or nothing. Everything is properly managed by this provider scope, which is a huge plus compared to something like service locators, which are notorious for not being tied to Flutter really, and you just need to like kind of make them work with Flutter so that everything is disposed properly so that you don't consume memory when you don't need to, you can release everything. No things like this here. Riverpod just works with provider out of the box, and it's not even obnoxious. You don't need to create a bunch of widgets everywhere. This is it. So now we have the provider all declared and set up, also the provider scope. But before we actually go ahead and implement the counter page where the text will be displayed and the floating action button will be, because we want to showcase a bunch of things regarding Riverpod, we also want to have the home page here, but this home page is totally dumb. It's literally just a stateless widget containing a single button that will navigate to the counter page. So if you would excuse me, I'm just going to copy the home page from the written article. Again, you can get to it from the link in the description, and I highly recommend that you do so because you will be able to copy this code also without any hassle from the article. So homepage is literally just a scaffold and button, elevated button that navigates to a counter page, which we currently don't have yet, but we're going to create it right now, basically, right after we set the home page to be the home widget of our material app, just like that. So now let's go ahead and create the counter page, shall we? So we're going to start it off as a stateless widget, counter page, and this is where we're actually going to use the counter provider from. But before we worry about any of that, let's just first build up the counter page so that it looks as it should, but it's not going to have any functionality just yet. So let's start out by making this container into a scaffold, of course. And this scaffold will contain app bar, boom, classic app bar, which will have title, whoops, which will be const text counter. All right, so that's pretty straightforward. And then we are of course going to have the counter text. So this will be a body of the scaffold, which will be centered text. So center text, whoops, child text. And this text for now will contain just the hard-coded number 0, which we can need to convert to, or we actually can just write the string, of course. And we also want to style this text. So we're just going to come in here and say that style is theme.off.context text theme dot display medium. This is going to make it look nice. So this would have the text handled, and of course we also want to have the floating action button. So this is fairly a classic thing when it comes to counter apps, of course. So floating action button will be a floating action button that is going to have a child. This child will be icons.add. Let's also make this const. And of course, we also want to have onPressed here. So onPressed, which will be just a blank function for now. So let's check out how this looks right now. It should be looking pretty much the same as in the showcase app I showed you before. And here we go. We can go to the counter page from here, which does its thing. And of course, we have the text and the floating action button, which currently doesn't do anything, but that's about to change right now. So let's do just that. What we want to do here is that, firstly, we of course need to be able to increment the integer held inside of the state provider whenever user presses the floating action button. And then once that happens, we need to be able to get the integer from this counter provider and show it inside of this text. So this means that in addition to just getting the value out of the counter provider, we also need to be able to rebuild this widget, or at least the text widget, but we're actually going to rebuild the whole widget when the integer is incremented, when the value changes. So these are the two things we are going to focus on right now. And for all of that to happen, we need to have access to the counter provider. With Riverpod, to get access to your providers, you need to make your widgets into consumer widgets. So here we go, consumer widget. This will add one more parameter to the build function, which will be of type widgetRef. Let's call it ref. And now we can use this ref to obtain, like, watch, read, listen to. We're going to cover all of these terms, what they mean, but we can do pretty much that. Watch, read, listen, invalidate, reset, whatever, individual providers using this widgetRef object. And by the way, you can also access your providers by not just always making your whole widget into a consumer widget. You can also use different ways. You can also use your providers not just from a stateless widget, which doesn't have any state, right? You can also use them from stateful widgets, which have the widget and the associated state. I'm not going to cover that here because that would take quite a long time, but of course I recommend you to check out the documentation of Riverpod. Once you know the basics from this tutorial, going through the documentation will be very simple. You can just pick and choose what you need to know. Links to all of that are in the article, of course. What we now want to do is that inside onPressed, we want to increment the state. So that means the integer. We can do that by getting hold of this widget ref called ref. And then we have a bunch of different options. Now we want to choose read. And what do we want to read? Well, we want to read our counter provider and increment the integer. So can we do something like ++ here? Well, not quite. This read, what it's going to give us, if we take a look, just put it in here, this x will be of type int. And sure, we can increment this int right here, but this is just a local int. It's not referring to that int we have in the provider state, so that's not going to do us much good. So instead, we cannot just read the counter provider, which will get us the state. We don't want to get the state here. We actually want to get to the actual thing which handles the state, which we can increment. We want to get to the mutable part. We can get to that by calling Notifier, or by getting Notifier. This is a specific of the state provider, also of state notifier provider. So really all these kinds of providers have their specifics, which you can learn about either from here if we cover them in this tutorial, but there are way too many providers to cover. So you can of course learn about everything from the beautiful documentation that Riverpod has. And this notifier, which manages the state, exposes state. And the state is actually the int. But this time when we get this int, it's actually the mutable int. We of course get to it through getters and setters, but this is mutable. If we mutate this, it's going to mutate the actual state held inside of the provider, not just some local int as we would have done previously before we used notifier and state. So incrementing the integer is now handled. How can we read it, right? Well, we want to read it kind of from here, from this text, but actually we can just read it at the top of the build method. It doesn't really matter, and put the result inside final counter, or int counter to make it clear. And how are we going to read it? Well, we're not really going to read it. We're going to watch it by calling ref ref.watch, and now we want to watch counter provider, and this time we actually just want to get the int. We don't want to mess with the notifier and state because we don't want to mutate anything. We just want to read it. But why are we here using watch and here we are using read? Well, these two verbs kind of speak for themselves if you're familiar with these kind of programming Flutter terms already from other packages, other classes. Watching something means that it's a continuous thing. We are watching something, and if this value provided by the counter provider changes, this watch will make sure that this consumer widget, in our case counter page, will get rebuilt. So we get automatic rebuilds if you say ref.watch, the counter provider value changes, the whole widget is rebuilt. On the other hand, ref.read will not rebuild anything if the value changes. This is just a one-time read. And this is precisely what we want inside onPressed, because this is a function which gets triggered by the user when the user presses on the floating action button. So we don't want to watch anything. We don't have anything continuous to do here. We just want to read it one time, increment it, and we are done. And actually, if we used watch from this onPressed handler, we would get into a lot of trouble. So we don't want to do that even. And now we have this counter readily available. So we can just put it here inside the text, say counter.toString. Let's just hard restart the app for a good measure, and let's check out how it works now. Go to counter page, increment, boom, nice, works nicely. Go back. All right. We go back to counter page, the state remains present here. So how can we make the state just be reset whenever we go to the home page and then come back? Well, we can just use the so-called auto dispose modifier on our state provider. So we're going to say state provider.auto dispose, and just like that, of course, now we have errors because we have changed things while the app is running. So let's just hard restart. And now if we increment, go back to the counter page, the state is reset. And you may wonder, why would we want to do this? Like, why on earth would this be valuable? Well, with this counter, it may look kind of silly, and I don't blame you for it. It actually is silly. But if you have some real world app and you are in one page or in one part of the app where some expensive object is used, it takes up very much memory and so on. If you exit that page or that part of the app, you probably want to release the resources held by that expensive object. You just don't want to keep them in memory forever, right? Because it's expensive. Maybe even the user will not come back to that part of the app very soon. So it would be unwise to just hold resources in memory when they don't need to be in memory, right? You just want to release everything. You want to keep your app consuming as little as possible, because the battery life will suffer otherwise and all that bad stuff will happen, right? So in that case, if you have some big object, disposing of things whenever they are no longer used is very handy. And how does Riverpod know that our counter provider is used only from this counter page and not from the home page? Therefore, when we come to the home page, it's disposed. How does it know that, right? Well, it all has to do with how provider scope manages stuff, and also how consumer widget remembers stuff and also passes information to the individual providers which are used within this consumer widget that, hey, I've been just disposed. If you are used just from me, meaning from this consumer widget, you probably might want to dispose yourself as well, right? But we don't need to worry about any of it. It's all handled by Riverpod. We don't need to write that disposal code, no disposal logic. We cannot even forget about anything. All we need to do is just add this auto dispose modifier and it's handled for us. Zero hassle added. Let's now remove this auto dispose modifier because it's not very fitting for our app, but it's good to know about. Of course, now we have errors, so let's hard restart. But now let's say that you actually want to dispose of the state or reset the state manually. How can you do that? Well, inside counter page, in the app bar, let's create one action, which will be icon button. And in the on press, we want to reset the state. And the icon will be icons, refresh. All right. And so how can we do that? When this button is pressed, which looks like this, we will want to reset the state. Well, actually, we are in the wrong page. So not home page, of course, but counter page. Sorry about that. So how can we do this, that when this button is pressed, the state is reset? Well, it's pretty simple. You may have already seen the function before as we were writing the watch and read functions. This time we're going to write ref dot invalidate, and we want to invalidate the counter provider. What this is going to do, of course, is obvious. When we increment the provider, we invalidate it, it gets reset back to its original state, which is 0. Sometimes you may also want to use refresh instead of invalidate. The difference is that invalidate is a bit more optimized, but also refresh returns the newly set state. In this case, it would contain the value 0 because that's the default value, whereas invalidate returns void, so it returns nothing. So by now you've seen that we can use watch to continuously, watch a provider and rebuild the widget whenever the value changes. We use read to perform one-time read, and this is very useful and actually mandatory from something like on-pressed callbacks for buttons and stuff. And then we also have invalidate, which resets the state. But how can we trigger something like navigation or show snack bars or dialogues, alerts, and so on, or any kind of other action? How can we do that? Let's say that we want to show a kind of stupid, but still kind of funny alert whenever the counter value is greater or equal than 5, because by our rigorous research we have determined that the counter value 5 is dangerous, so we want to warn the user that, hey, you're in danger, the counter is 5 or more than 5, right? We want to show an alert dialog when that happens. Well, we have this counter value already available here, but of course, if you've been doing Flutter development for quite some time, you know that you cannot just come into a build method and start navigating or start showing alerts or snack bars from here, because you are going to get the infamous error set state or mark needs build called during build. Basically, it's just impossible to perform some kind of action which draws something while you are drawing something on the screen because you are inside a build method already. So you need to put this snack bar showing or alert showing into a separate function which is run after the build has finished. So therefore, using watch for this is not possible. Instead, what we are going to use is ref.listen. This also continuously listens on our counter provider in this case, but instead of putting the value into a variable like this, we are instead going to receive the value inside a callback. Actually, two values, previous and next. we are not really interested in what the previous value was, so we're just going to focus on the next value, which is currently actually the current value, right? For some reason, we have two parentheses pairs here. Anyway, here we can check if next is greater or equal 5. And if it is, which obviously currently it cannot be because type inference doesn't really work here, so we need to say that listen happens on type int. Just like that, everything works. And if it's greater or equal than 5, then we want to show a dialog. And to spare you from this dialog code, which is kind of monstrous, unfortunately, I'm just going to paste it in here because it's very, very simple. What we do here is just show dialog and say that the counter is dangerously high, and then we can pop the dialog from the OK button. So let's see how that works after we fix this code by adding a parentheses and everything. All right, and after fixing the missing parentheses and curly braces, let's see how that works. So we increment the counter, number 5, and we get warning, dangerously high counter, consider resetting it. And we always get it until we reset it, and now we're safe, unless we increment it back to 5, and then we are no longer safe. So this is how you can perform some actions like navigation or showing alerts, showing snack bar, or any kind of other logic which needs to happen only one time per state change, because as you should know, build functions are not good places to run your logic, which needs to run only one time per state change. Because even if you're not showing dialogues or you're not doing something which will give you that infamous error, which says mark needs build called during build, even though you're not going to get that error, still, if you have something like if next is equal to 3 and you do some logic here, right? Or in this case, it would be if counter, of course. Logic inside of here can actually run multiple times because build function can run up to 60 times a second, even maybe more if you're animating the widget. So you cannot rely on the fact that if statement will just run once inside a build function. So every logic should happen inside listen when you are working with providers and you need to run some logic or show dialogues and stuff. Up until now, we have worked in this app with just a single counter provider. So there were really no inter-provider dependencies we needed to resolve. But in real world apps, of course, you are not just going to have one single counter provider. You're going to have a bunch of providers. One can be for a qubit or change notifier. This will depend on a repository, which is provided by yet another provider. So you're going to, in real apps, have kind of chain of providers which provide objects that kind of depend on each other. And you need to be able to resolve all that. Thankfully, providers make dealing with dependencies totally simple. And in fact, even though you may not know it yet, you have kind of seen the syntax which is used for dealing with inter-provider dependencies. Just saying, you will see once we actually use that. So let's say that we want to upgrade our familiar counter app to be a lot fancier, because everybody knows that keeping all of your state just local like this is lame, you know? And the cool kids put everything on serverless servers, and we surely do not want to fall behind this trend, of course. So we will create the ultimate counter app that gets its counter integer value through a WebSocket. Well, sort of course, because we are not just going to use actual WebSockets. We want to keep this app tutorial friendly, so we're just going to fake everything with the fake Websocket Client, which will just be a local stream of data. But nevertheless, this would all work for like actual WebSockets even, right? So what we are going to create now is a Websocket Client, which I'm just going to copy and paste from the written article, and also its implementation, fake Websocket Client. But of course, you could apply this interface on a class which actually communicates with a WebSocket. That's totally possible. And in here, we have a function getCounterStream, which in our fake implementation will of course return stream of integers. And this stream of integers is just going to be constantly incremented starting from the value 0 after 500 milliseconds. It's just always incremented, and we are yielding a new value into the stream. So every half a second, the integer will be incremented and it will be sent down the stream and wherever we then consume it. So there are going to be no like buttons involved, no user interaction. Everything will happen sort of like from the server, from this fake server, of course, fake WebSocket client. So let us provide the fake WebSocket client, right? We're going to create a provider, final, WebSocket client provider, which is going to be of type just a regular provider. And let's also use this WebSocket client abstract class type so that we don't expose to the outside world that we are actually using a fake implementation here. And we're just going to, well, return from here the fake implementation, fake WebSocket client. So this is pretty simple, but this is not the end provider that we want the UI to have access to. Because yes, this provides the WebSocket client, but we actually want to get to this stream of integers that's provided only once you call getCounterStream on this WebSocket client. So we need to provide the stream also, right? So we're going to provide this stream in a provider called CounterProvider again, which will no longer be a state provider, but instead a stream provider. Let's also designate that it's going to be of stream integers or stream int. And let's make this into a blank regular callback. And so what needs to happen from within this callback function? We need to get access to our WebSocket client, which in this case is the fake WebSocket client. But of course, we could swap it very easily using providers to a real implementation. That's the beauty of it all. Inside a test, we would of course use this fake WebSocket client so that we don't communicate with a real server. But inside a production app, we would use the real implementation. But how can we access this WebSocket client from a counter provider? We need to access this provider from counter provider. And the way to do that is by using this ref parameter, which is not widget ref this time, but it's instead a stream provider ref. But it works pretty much in the same way. What we can do is call ref.read or ref.watch, ref.listen. All this remains the same. We have also some other methods you can call like onAddListener, onCancel, onDispose. But this time we just want to call ref.watch. And we want to watch the WebSocket client provider. So this is exactly the same syntax as you've already seen. We're doing the same thing. We're watching WebSocket client provider. Previously, we of course watched the counter provider here. Same syntax. So what we want to do from this counter provider, of course, we want to put this WebSocket client into final WS client. And now we want to return WS client dot get counterstream. So now this stream of integers, which are incremented every half a second, is available through this counter provider. Now let's go ahead and use it because our counter page code is currently quite broken because we are no longer dealing with any user interaction nor with any just state provider. We instead have a stream provider. So let's reflect these changes in our code, shall we? Firstly, let's remove the user interaction. So we're going to get rid actually also of this listen because that's going to become quite obnoxious. The listener goes away. Also, what goes away is the floating action button because there is no need for it. We don't have any user interaction because we're cool and we handle everything through WebSockets, serverless servers, right? We do want to still watch the counter provider, but the difference is that now it no longer provides just an integer. Instead, what it provides is an async value, which wraps an integer. Because we are using a stream provider, this allows us to use some optimizations so that we don't actually need to deal with just plain streams in our widgets, which would require us to use stream builders and so on, but we don't want to use those stream builders because they are quite cumbersome to work with, right? So instead of just having a stream here that you need to handle through a stream builder, you have async value, and of course it still applies that whenever the stream changes its value and you receive new async value, this whole build method will be rerun, so the widget will get rebuilt because we are using the watch method here. Also, let's remove this invalidate action button and let's restart the app while we are at it. Now, of course, if you want to use stream, it's totally possible. You just need to say counterprovider.stream, and now that's going to give you a stream of integers. But again, we don't really want to do that, so let's just stick with async value. But again, the Riverpod is very versatile, so if you just absolutely need to have stream present, you can do that too. So this counter is of type async value, no longer it's just a simple integer, but let's just leave this text to directly convert counter to string and see what happens. Once we open up the app, go to counter page, boom. Now we see async data int, and the value is of course incremented as it should be. And also when we go away from this page, wait for a while, come back, it's now 26, well, it's 30. Let's wait for a while. It was 30 when we went away. Now it's going to be like 44. So the counter keeps on counting even though we are away from this page because we don't have the auto dispose modifier on our counter provider right now. But of course, we don't want to have this weird async value displayed here. So what can we do? How can we display just this integer? Well, the async value is a union, which kind of works like freeze unions. So if you are familiar with the freeze package, you will know immediately what I'm talking about. If not, no worries. What we can basically do with counter is to say when, and when the data is, data, this means that there is a readily available integer value in this case, which we can display. So int value, and we're just going to get the value out of there. There is also an error case on this async value. So if some kind of an exception happens, you're going to get this passed in this error clause of this union async value. So this will give you object E, which will usually be an exception, but it also can be any kind of other object because of Dart's history, and also a stack trace, but we don't want to worry about the stack trace, so we just give it an underscore, and we're just going to return E from here, which is of type object. And we also have the loading case, and the async value will be in the loading case until it receives the first data value, so the first integer, or until it receives error, whichever comes first. Until then, we're loading, which basically means that we don't have a value yet because streams are asynchronous. So of course it can happen that you don't have a value yet. In that case, we're just going to return 0 because while we are loading the first value from the stream, we want to display 0 in the app for nice user experience. And now let's just call toString on whatever is returned from this when function, because whether it's the actual value or the error or just the 0, we just always want to display it inside of a text, so we need to convert it to string. Just like that, when we come back to the app, now the counter is at 250, so it never stopped counting, but it looks much nicer now. Lastly, let's deal with one more thing in this tutorial. The current implementation of the counter client always starts from 0, but suddenly our customers started giving us 1-star reviews saying that they need to be able to modify the starting value of the counter, and so we naturally, as great business savvy programmers, implement their feature as fast as possible so that bad reviews cannot damage our reputation out there. So first, we of course modify the implementation of our WebSocket client or fake WebSocket client, and we modify the interface of the WebSocket client. So now it will look something like this. And of course, I copied this from the article. Again, you can get to it from the link in the description. What happened here is that we just simply added an optional parameter, integer start. By default, it's equal to 0. And the starting value is, of course, taken from this start integer and not just hard-coded to 0. And that's about all the difference there is. So now what needs to happen is that we need to be able to pass in this starting value into our counter provider, right? Because we absolutely need to be able to pass our starting value into this getCounter stream, right? It's optional, so it doesn't scream at us with errors, but we totally can pass in like 5 or 10, and we want to be able to do that, but not hard-coded here. We want it to happen from the user interface because the user should be able to pass whatever value the user wants by a slider, or maybe there is a text input field where the user inputs values. And whenever we watch the counter provider, we need to be able to pass in the starting value right here. So how can we do that? How can we pass something into a provider? Because when you think about it, until now, every single provider we have taken a look at always contained everything it needed. We never needed to pass in values. It always contained all of the values it needed by itself. No outside values were needed. So how can we change that? Well, it's very, very simple with Riverpod, and that's exactly what the so-called family modifier is for. So we're going to scroll up into our counter provider, and we're going to make this stream provider into a family. And now it needs to take in another type parameter, which will be again int. So in this case, these two type parameters are identical, but the first one is the type of the stream. So we have stream of integers, and the second one is the type that you want to pass in. So this is the starting value, right? And by the way, you can totally make your providers both auto dispose and family at the same time. That's not a problem. You can do it like either like this. Auto dispose comes before family, or auto dispose comes after family. However you want. It's totally possible. You can use multiple modifiers on a single provider, no problem. Now this integer will be passed in as the second parameter of the callback. So let's say that it's going to be called start. And now we can pass the start value into our getCounter stream. as easy as that. And we also want to pass the start value into the counter provider. Now, of course, in a real app, if this was not a tutorial, we would let the user pick a value by a slider or through a text form field or something like that. But here we are just going to hard code it right from the UI. Let's say that the start value is going to be 5. Of course, we have problems, so let's hard restart. And we go to counter page, boom, and it starts from 5. Of course, though, we cannot just do that, because as you have seen, when it starts from 5, the initial value is 0, right? 0, and it jumps to 5. So we probably would want to either move this yield to happen before we await the future, so that we immediately have a value. So let's hard restart again and see how that works now. Boom. And we see 5 immediately, and it starts incrementing from there. Or also, if we didn't want to do this, we want to keep the old implementation of the fake WebSocket client, we would probably just want to also modify the value for the loading status. So that would be 5 again also, and it would look something like this. All right. And just like that, you have learned how to use the powerful Riverpod package by building and expanding upon the simple counter app. So you're now ready to employ all of this knowledge in your own complex and cool apps that Riverpod makes hassle-free to build and easy to maintain, or at least when it comes to getting the objects around your app. But at least Riverpod takes one painful thing away from the app development process, and you can focus your efforts where it's actually needed, creating great apps, great looking apps, focusing on the logic, and Riverpod will take care of all the hassle for you when it comes to providing things around your app and doing state management. So to go through this tutorial at your own pace once again, and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the video description by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Because over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this about Riverpod, about state management, but also about design, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. Alright, so if this video helped you, give it a like and also share it with other people who are surely going to benefit from it too. Leave a comment if you have anything to say, and see you in the next video.